Welcome to Freedom with DSA. In this presentation, let's make an algorithm walkthrough for the second largest element. The name of the approach, single pass approach, a single pass dry run. This is the given unsorted input array and the largest element is 35 and the second largest element is 34. We need to return 34 as the expected output. In our previous approach, we used the two-pass approach where we traverse the array twice to find second largest element, but we can do better. Can we find the second largest element in just a single traversal? Absolutely. So let's move forward. Now let's move to our final optimal approach, the single pass approach. Before looking at the code, let's understand complete logic using this flowchart. So we start the program and we find the length of the array and store in n, and then we initialize two variables, largest and second largest. Initially both are set to 1. We start our loop and visit each and every element of the array one by one. So this is initialization phase before the loop begins. So n is the size of the input array containing 6 different elements, 12, 35, 1, 10, 34 and 1, and largest and second largest is initialized to -1. So this is the entire initialization is done. So if you observe on the top, we have 3 different phases: initialize, loop, find both, and return result. So we have successfully accomplished the initialization phase. Now here is the traversing begins from the index I is equals to 0 till the last index I is equals to 5. So what is the condition and what is the criteria in order to update the largest and second largest? So here is the loop starts from the index I is equals to 0 till the last index n minus 1. So we will check the two conditions. First, we will check the condition current ARR of I value must be greater than the largest. As you can observe, in the previous initialization, the largest is initialized to -1, and now it is updated to 12. What is the criteria? Simple. The current ARR of I value must be greater than the largest. That means the current ARR of 0 value is 12. This 12 is greater than -1, which is initialized -1 here, largest. So as 12 greater than -1, the condition is true. Now we will update the largest is updated to 12. If I update largest to 12, then whatever the value which is there in the largest in the previous initialization, that will be transferred to the second largest, which is -1. Okay, so once again I'm repeating for better clarity. So in the previous initialization phase, the largest is -1. So when I update this largest -1 to 12, then you can get a doubt. Then what about the -1 which is initialized to the largest? This -1 will be transferred to the second largest element. As you can observe, when ARR of I value greater than the largest, when this condition immediately becomes true, then whatever the current largest value is there, that is assigned to the second largest, and new ARR of I value, the current value, is assigned to the largest. As we move forward, you will get a better clarity. So the largest is updated to 12 at the index I is equals to 0. Now let's move forward at the index I is equals to 1. Now if you observe, the current ARR of I value is greater than the largest. 35 is greater than 12. Condition is true because in the previous iteration, the largest is 12 and this 35 must be greater than 12. The first condition becomes true, and this 12 which is assigned to the largest in the previous iteration at the index I is equals to 0 will be transferred to the second largest. This 12 is assigned to the second largest at the iteration I is equals to 1, and the new current ARR of I will be assigned to the largest. Hope you understand. As you can observe, the updation here, the second largest 12 is updated to 35. Yes or no? Here second largest is -1 is updated to 12 and the new current largest value 35 becomes the largest. This is the way we check the condition. In this way the story keeps on repeating till the last index I is equal to 5. And as we move forward at the index I is equals to 2, if you observe the current ARR of I value ARR of 2 is equals to 1. The 1 is not greater than 35. Condition is false. The first condition becomes false. When the first condition becomes false, you will check the second condition. Is my current ARR of 5 value is greater than second largest? 1 is greater than 12? No. The condition becomes false. So there is no updation of second largest also. So we move forward and I moves to the third index. At the index I is equals to 3. ARR of 3 value is 10. And again check the condition. 10 is greater than 35. Is 10 is greater than 35? No. Is 10 is greater than 12? No. So the first condition and second condition, both conditions become false. So there is no change. So no updation of largest and second largest element at the iteration I is equals to 3. As we move forward at I is equals to 4, here you can observe 34 in the previous iteration at index I is equals to 3, there is no updation. But as we move forward, if you observe ARR of 4 means 34 is greater than 35. Sorry, 34 is not greater than 35. First condition becomes false. The index I is equals to 4. But if you check the second condition, 34 is not greater than 35, but 34 is greater than 12 at the index I is equals to 3. Yes, no. If you observe, 34 is greater than 12 and also 34 is not equal to 35. Yes, 34 is a different value from 35 and 34 is greater than 12 according to the previous iteration at the index I is equals to 3. So both conditions are satisfied. So then we are allowed to update our second largest, which is 34. So in this way, we need to check the conditions in order to update largest and second largest so that we will get the desired result, the second maximum value in the entire array. Hope you understand. So this is the process we follow at the, now let's move forward and at the index I is equals to 5 and 1 is not greater than 35, condition false. Again 1 is not greater than 34 also. So here also second condition becomes false. So no updation. So finally we traverse the array from the index I is equals to 0 till the last index I is equals to 5. So here finally once the loop is completed, second largest contains the largest element and we finally return this element. So in a single pass we continuously maintain two values, the largest and second largest, and that is how we find the second largest element efficiently in this optimal approach. So the single loop has scanned every element exactly once. Largest is 35 and second largest is 34, both discovered together in one pass instead of needing a second scan. As you can observe in the previous better approach, we traversed the array 2 times, but here we traversed the array single time and we check the condition by making some modifications, a smart modification and change. We are making updation of largest and second largest one at a time by checking the conditions. Hope you understand. So this is the core algorithmic logic building intuition of a single pass approach in order to find the second largest element for the given unsorted input array. Now it's time to return the result, the final result. The function returns second largest 34 and this matches the expected output for the given input array ARR. So now it's time to analyze the time and space complexity for the second largest element, the single pass. The linear time complexity big O of n and the space complexity is big O of 1. We didn't use any extra data structure, so the space complexity is constant. The array is scanned just once. At each index, largest and second largest are both updated in the same pass. So this is the entire intuition of single pass followed by the time and space complexity analysis. Hope you understand. Let me demonstrate the code execution using Java programming language. Here is a given unsorted input array ARR, and we used this test case in our core logic building intuition, as you know. And the largest element is 35, second largest element is 34, and as you know, this is a single pass approach and the time complexity is linear time complexity big O of n, and we didn't use any extra data structure. The space complexity is constant. So without any delay, let's demonstrate the code execution. The first line is import space java dot util dot star class space name of the class is main. Why? Because here before dot java the name is main, so we need to give class space name of the class as main. And now we will start the execution. So public static, and the output data type is int. So int space the name of the function is second largest, and array data type is int, and name of the array is ARR. Now let's define and declare the size of the array. Int space, let's say the name of the variable n is equals to ARR dot length. This is the size of the array. Size of the array ARR. Now we will declare two variables, int largest equal to -1, int second largest equal to -1. Now here we need to run a loop, for loop int I is equals to 0 and the condition I is less than n, and we need to increment I by +1 in each and every iteration I plus, and this is a single loop traversing from index I is equals to 0 to till the last index I is equals to n minus 1. So here we need to check the first condition. If the current ARR of I value is greater than the largest, then here we need to assign the largest value to the second largest. That is the reason I'm typing in this manner to understand in much better way. I am assigning the largest value, the current largest value, to the second largest, and then now we will update the current ARR of I value. The current ARR of I value is assigned to the largest later. First we need to assign the current largest to the second largest, then followed by the current value ARR of I value to the largest. So here this is the condition. We will check the first condition. Check the first condition. If the condition is true, then update largest. Hope you understand the first condition. This is the first condition. Else When the condition becomes false, when the else part gets executed, if first condition the first condition becomes false, else part gets executed. So in this else part, we'll check the condition if the current ARR of I value must be greater than the second largest, and we will check one more condition in order to get the absolute second max. Then we need to check one more condition: the current ARR of I value must be not equal to the largest. If these two conditions are satisfied, then only we will update our second largest as ARR of I. So here we are checking the second condition. Simple. Let's replicate this same comment for the first index at this line. Just update and replace this first with second. So check the second condition. If it is true, then date second largest. Hope you understand the entire logic here. For this is the optimal approach. Okay. So we are traversing from the index I is equals to 0 till the last index n minus 1, and we will check the first condition followed by the second condition. Once if the entire execution and entire traversing is done till the last index I equal to n minus 1, we will come out of the loop. Once we come out of the loop, we need to return second largest. So now we will declare main method, which is public static void main string args. So array data type int, and name of the array let's give as arr1, and let's replicate the comments. Let's replicate the values whatever there in the comments section, which is 12, 35, 1, 10, 34 and 1 as it is. Copy paste. Now system dot out dot println, and we need to pass the function second largest. We need to pass the second largest function and the name of the array for the first test case arr1. We need to pass the name of the array. Now let's try to replicate the test cases again and again 2 more times in order to execute the second test case and third test case as well. Okay. Sorry, just a second. So here we need to copy this entire 2 lines again and again. We need to replicate 2 more times. So hope you can guess the test case what I'm going to write. If you follow the first and second approach, in the naive approach, in the better approach, we replicated these 2 test cases. So here the test cases are: what if the largest element duplicated twice, 35, 5, 35. This is the second test case. And in the third test case, the duplication of the largest element at all the indexes 35 comma 35 comma 35, and when to change the name of the array, which is ARR2 in the second test case, and we need to convert ARR3 in the third test case. So we need to give the naming conventions for the individual test cases as ARR1, ARR2 and ARR3 respectively. So this is the entire core logic building intuition. This is the core logic building intuition for the second largest element, the single pass approach. So this is the most efficient and the final optimal solution for the given problem. So this is the journey of improving the efficiency of the algorithm from the basic intuition naive approach to the final optimized solution. So hope you understand the feel of the optimal approach. If I explain this optimal approach directly, you will never get the feel, the struggle what we faced in the naive approach and in the better approach. So we overcome those challenges and the unnecessary computations by implementing this optimal approach. Hope you understand and enjoyed this journey of improving efficiency of the algorithm. So let me run the code. So let me run code once again for you. So here 34, 5 and -1. So for the first test case ARR1, 34 is the second largest element, and for the second test case 5 is the second largest element, and for the third test case there is no second largest element, and we simply return -1 as the answer. Keep practicing, keep improving, and if this explanation helped clarifying the concept, consider liking the video and let me know in the comments if you have questions or want me to cover a related topic. Subscribe to stay updated with the rest of the series. See you in the next video. Thank you. Have a nice day.